All right. Hello. Today we'll be doing a problem that's not on Leetcode, still doing depth first search. Yeah. So basically, we want to see, um, given a binary tree and a number sequence, find if the sequence is present as a root to leaf path in the given tree. Right. So I guess it's pretty similar to see um, I mean, it's you just have to go through and then just make sure the path is exactly the same as the sequence, which isn't too bad. Um, it as long as you look at the node that you're currently at, and you just see if you're at the right number. If not, you just return false, right? And if you are, then you keep going downward and see potentially if you can find the right node. So yeah, we'll be coding up the solution now, I guess. So we're going to define a helper function because um, I do this with recursion. I find depth first search with recursion a lot easier than a stack. I believe it is possible with the stack. I just am not too sure exactly, I guess, how I would do that. Um, and yeah, well, okay, yeah, it's not too clear to me at least, but I'm pretty sure someone does it out there. So without further ado, we will go ahead and do our solution. So with recursion, so we have our helper function here. We're going to have a node, which is an optional tree node. Oh, tree node. We're going to have the sequence, which is a list of int. So basically we have everything that, we have in find path. And then we're going to have another thing called index, which is the way I'm going to keep track of where in the sequence we are currently. So we have, a few base cases. So if not node, um, we want to return false because if we're at a node and it's, not even, if it's like null or none, we obviously don't want to deal with it. So we'll just do if not node, uh, or index is greater than or equal to the length of sequence. Because basically that just means we're beyond the bounds of the sequence, so we have a way too long of a path. So there's no point in even handling for that. So we can go ahead and just return false here. We have another instance where we do want to return false. It's if sequence index does not equal to um, node.value. Because if at our current node, we're trying to look for, let's just say in this case, right, we want to look for 116 because we know 116 is a possible, path. If we're here, I guess, no, we need to use the other example, 107, 10, and 7 is not an actual path, right? So when we're at 0 and we go to this node, we go to this node because we're looking for 7, and it's not the right value, we can just go ahead and, return false. We don't need to, go to its children and be like, oh, actually, yeah, we can go to its children and be like, oh, it's actually false, and return false upward. We can just break out and do it here. I think it's actually possible for you to do it here as well. Because since it's evaluated left to right, you do already know you have a node. You already know it's out of bounds. If it's in bounds, so you have a node, it's not out of bounds. So you could do the check here. But, I guess logically speaking, this is just for like out of bounds stuff. And this is like valid, a valid check, but you just want to make sure that it's a valid check. It's just you want to know if it's giving you the solution that you want, right? And for the return true part, we want to make sure if index is equal to length of sequence minus 1. So this means we're at the very last index, And we know all of the values have been true so far because, all the values match up so far because they haven't returned false prematurely. And we want to see not node.left and not node.right because we don't want any children, right? And that's our check for no children. We want to return true here. This means we've gone from the root to the root to the leaf without going out of bounds, without finding any null, with matching all of the values to the sequence and its index, and then we made it to the last index, so which means we have the same length exactly, and we have no children nodes. So that's how you know we can return true. And if we don't return true either to we're not being on the last node, or we do have children, we will go ahead and do return find path helper node.left. We still want to pass in sequence because that doesn't change, and we pass in index +1 because we want to increase the index because we don't want to look at the same index that we did in the call right before, right? And since we don't know which side is no children or not, we need to do it on both sides. And we already have the failsafe of if it's not if there's no node there, we just immediately return false anyways. So there isn't like a downfall, so to say. I guess here we can just do this instead. Whoops. We can just do this instead, just to save us from doing this twice. Index. And then remove that. So there we have that. And we come up here because we need to finish off our solution. If not root here, we can have a different different edge case here, because we know this only happens at the root. We can't do this anywhere else. If it's not the root, we can return the length of sequence equaling 0. So that means we didn't expect the path anyways. This is a very niche case. This will only happen once out of technically infinite number of paths that you could try. But since this is Leetcode, since this is preparing you for interviews, anything could happen. So I guess this would be a valid, path that you would want to go down. And so, but most of the cases we'll go into find path helper anyways. We're going to pass in root, we're going to pass in sequence, I'm going to pass in 0 because, we're starting from the 0th index. And then this will do recursive function will do everything else for us. So without further ado, I guess we can just test. This should end up being false. This should end up being true. I can actually draw out this tree for us really quick. So if I draw the 1, 0, 1, left is 1. So if I shimmy these over a little bit, 6 and then 5. So 6 and then 5. If I shimmy this over like this, shimmy this over a little bit, it looks kind of funky, but I mean, as long as you get the gist of it, right? Like 1, 0, 1, and the 1, 6, 5, right dot left, right? Right dot left. So there we go. We have our tree. We see 1. We start from the root, 1, 0. And we come down here, it's not a 7, so that should return false. 1, 1, 6 is a valid path. So therefore, if we did this problem correctly, we should have 1 false and 1 true. And so if I run Python file in terminal, name optional is not defined. Okay, I guess my bad. I guess that's something that maybe I have to add in like imports or something. I'm actually not too sure. You typically see it on like Leetcode, stuff like that. So I guess I just can't do that. Just know that that optional is meant to show whether or not, I guess it's essentially to represent like, oh, this class could show up as none, right? I think that was the purpose of it. So that's why I wanted to use it. But just remember, tree nodes can show up as none in our binary tree. And so we will run it again. And there we go. We have our expected answers false and true. Um, yeah, I guess without anything else, that's the problem. Thank you for watching, and guess I'll see you again. Well, I guess I won't really see you, but yeah, see ya.